All right, so previously we just looked at side to side and up and down movement. So hypothetically, say your new function is fx minus 4 and minus 5. Then it's pretty easy. Like you just have to take a look at what happens to side, up and down. So this means to the right by 4 and then down by 5. Brackets are always opposite. So when you see minus, it's to the right, but the last number y value is straightforward. So when that happens, you just kind of go to some key points and then you move to the right by 4 and then down by 5. 1, 2, 3, 4, 5. And that becomes your new point. And then do the same with that other point. So to the right by 4, 1, 2, 3, 4, and then down by 5. 1, 2, 3, 4, 5. And then you can see how the connection is shifted, and then you can just finish the graph, make it symmetrical. Now the problem is sometimes that's not it. So we're going to introduce this concept called the vertical expansion. So vertical means the y value. We are going to stretch the graph by a factor of that number. So it's the number that is sitting at the front of the new function. Okay, so you have to do that transformation first. So that's step number 1. And then you can do the side to side and up and down movement from left to right. All right, but you do need to apply that transformation rule for each and one of them, not literally every single one of them, but some of the key points that we want to move, at least to see the pattern. So we are going to write down the transformation rules. So number 1 is that number 3 at the beginning of the new function h of x. Okay, so that's called a vertical expansion. Vertical expansion, which means vertically it is going to stretch, which might result in the skinnier graph. So vertical expansion means we are going to let's see. So multiply the y value by 3. So we're going to write down the rule before we actually apply the rule. Step number 2 is this one right there. Remember the brackets are opposite. So minus 4 means we are going to add 4 to the x value. And then we do the last one, minus 5. And then that one is straightforward. If you see minus 5, that means you're going to subtract. Subtract 5 from the y value. So write down the rules, and then we will be applying that set of rules to the key points. So one of my key points is the vertex. So let's take a look at negative 2 comma 1, and notice that it's always x comma y. So it is time to apply step 1, 2, and 3. So step number 1 says multiply the y value by 3. So y value 1 is going to be times by 3. So I'm going to get negative 2 comma 3. However, I'm not done yet. Step number 2 says add 4 to the x value. So previous x value is negative 2, add 4, that gives me 2 comma 3. We're still not finished. Step number 3 says subtract 5 from the y value. So from the previous y value, I go subtract 5. I end up getting negative 2 comma 2. So now you can go to the graph paper. Negative 2 comma 2 is your new vertex value. Cool. The thing is that 1 point is not good enough. I am going to see what happens to the previous y-intercept. So 0 comma 5 will need to go through the exact same transformation rules. So number 1, multiply the y value by 3. So this is the y value. I'm getting 0 comma 15 stretched way up. And then step number 2, add 4 to the previous x value. So now I'm at 4 comma 15. And then step number 3, subtract 5 from the previous y value. So 4 comma 10. So this y-intercept is probably not the y-intercept anymore because we moved it. So over 4 and then up 10 is right there. Okay, I'm actually just realizing that that vertex is not right. So it's 2 comma negative 2. So 2 comma negative 2 is down here. So I am going to mark them. This is the new vertex. And that's not the y-intercept, but this 0 comma 5 got moved to that one. So that's h of x. And then because it needs to be symmetrical, I need to go to the other side, and I guess that's the new y-intercept. So notice that it is skinnier, and all the points are moved. So let's do something very, very similar with the a value of -2. The a value is just the first number that determines the width or the height of the graph and also the reflection. So when there's a negative, you are going to reflect this graph in the x-axis. All right, so let's do the rules first. So remember, left to right, that's step 1, that's step 2, that's step number 3. So step number 1 is the vertical expansion. In this case, we have a negative value. So step number 1, multiply the y value by -2. Step 2, x values in the brackets, they're opposite, so we are going to not add, but subtract 1. Positive means subtract, it's opposite. Subtract 1 from the previous x value. And then the last one, step 3. Y values at the end, that's straightforward. We are going to add 8 to the y value, previous y value. Okay, as before, -2, 1 is the vertex, the key point. So let's move it. I am going to apply one rule at a time. So step 1, multiply the y value by -2, times that by -2. So -2, -2. Step 2, subtract 1 from the x value. So subtract 1 from the x value, that gives me -3, -2. So that was step number 2. Step number 3, add 8 to the previous y value. So add 8 onto -2, I'm getting -3, 6. So 3, 6, I guess that's the new vertex. And then 1 point is not good enough, so let's grab that y-intercept 0, 5, and then apply the same transformation rules. Number 1, multiply the y value by -2. So I'm getting 0, -10. Step 2, subtract 1 from the previous x value. So I'm getting -1, -10. Step 3, add 8 to the y value. So -1, -2. That was the last step. So -1 and 2 is there. And because we know this is the vertex, you know it's going to come down this way. And then we need to make it symmetrical. So 2 steps that way, 2 steps that way. You can do this rule or steps 1, 2, 3 using another point, like using that point or something. But because we're just sketching, as soon as you see the pattern, you can connect the dots together and then do the transformations that way.